Today we're going to be solving complex radical equations. So here we go. We have the square root of x minus the square root of x minus 5 equals 2. And remember, with these questions, our goal is to try and, obviously at the very end, get what x equals and check for extraneous solutions. But our first goal is to try and get each radical isolated on a different side of the equals sign. So if we do that, we're going to keep this radical x here. If we add the square root of x minus 5 to both sides, okay, that will give us the square root of x equals 2 plus the square root of x minus 5. And usually what would happen is we would just have a radical on both sides, and that's easy enough to just square both sides. So we're still going to square both sides here in order to get rid of that square root. On the left, we would just have x. On the right side, though, we do need to multiply this binomial by itself. So 2 times 2 is 4. 2 times the square root of x minus 5 is 2 square root of x minus 5. Square root of x minus 5 times 2 is 2 square root of x minus 5. And the square root of x minus 5 times the square root of x minus 5 would just be x minus 5. Now that we have this, if we clean stuff up here, so we have x equals, this would give us negative 1 plus 4 square root of x minus 5 plus x. Now that we have this, we need to try and again isolate the radical. So we're going to work on getting 4 square root of x minus 5 by itself. So we're going to subtract x from both sides and add 1 to both sides. Our x's are going to go away, and we have 1 equals 4 square root of x minus 5. Now we're going to get this radical by itself. So we're going to divide by 4. And we have 1/4 equals the square root of x minus 5. This looks more like a question that we would have seen previously. So now we're going to square both sides again to remove the radical. So when you square a fraction, we're going to get 1/16 because we square the top, square the bottom. And to get x by itself, we're going to add 5 to both sides. So x would equal 5 and 1/16. You can leave it like that. Or you could also make this be a fraction of 81/16. So we only get one answer here. We do need to go back and test it to see if it's extraneous or not. And remember, you have to go back to the original question to test, okay? So we have, so this is where we're going to check our answer. We have the square root of 81/16. It's going to be easier to use this as a fraction. Minus the square root of 81/16 minus 5, and we're going to see if that's equal to 2. Well, here first, the square root of 81/16 would give us 9/4. Here, this 5 we would change into 80/16. 81 minus 80/16 is going to give us 1/16. The square root of 1/16 would be 1/4. 9/4 minus 1/4, does that equal 2? Well, this would give us 8/4, and 8/4 does equal 2, so it does work. So this is your one answer there, 81/16 or 5 and 1/16. You could leave it like that as well. Okay. So remember, you don't necessarily have to show the work of testing, but you do need to test them. So let's take a look at this question. We have the square root of x equals the square root of x minus 8 plus 2. So for this question, we do have those radicals separated from each other, so we're going to go ahead and work on squaring both sides to get rid of the radical. That means that we are going to have x equals, and when we multiply this by itself, we would get x minus 8 plus 2 square root of x minus 8 plus 2 square root of x minus 8 plus 4. Okay. So cleaning stuff up there a bit, we still have x equals x minus 4 plus 4 square root of x minus 8. And as long as you have all three of these terms, it doesn't matter what order they're in. Okay? We're going to move everything away from that radical, so that means we need to subtract x from both sides, and we also need to add 4 to both sides. So that's going to give us 4 equals 4 square root of x minus 8. Next step is to get this radical by itself, the square root of x minus 8, so we're going to divide by 4 on both sides. And we have 1 equals the square root of x minus 8. That means that we're going to square both sides to get rid of that radical. So 1 equals x minus 8. To get x by itself, we're going to add 8 to both sides, and we're getting x equals 9. So if we test that, the square root of 9 is 3. Over here, the square root, so we would take 9 minus 8 and get 1. The square root of 1 is 1. 1 plus 2 is 3, which is what we got over here. So there's our answer. Again, I didn't show any work of testing, but if it helps you to do that, then please do so. Alright, let's take a look at this one. So we have the square root of x plus 10 plus the square root of 3 minus x is equal to 5. So the radicals we want to separate. It really doesn't matter which one you move over. Since both of these are positive radicals, it doesn't matter. So we're going to have the square root of x plus 10 equals 5 minus the square root of 3 minus x. Okay, we're squaring both sides. Instead of writing it as squared here, you could also just go ahead and rewrite it. Some of you are going to do that. Some of you are going to write it as squared and just know that it's written twice, and that's completely up to you. So here we would get x plus 10 equals 25. Here we would get a negative 5 square root of 3 minus x and another negative 5. So you could automatically combine those to get negative 10 square root of 3 minus x. And then when we multiply these two together, we would get 3 minus x. Alright, cleaning stuff up here, we have x plus 10 equals 28 minus 10 square root of 3 minus x, and then another minus x after it. So this is a minus x there. Okay, so we need to move the 28 over. And we also need to move this x from the right over to the left. So that's going to give us 2x minus 18 equals negative 10 square root of 3 minus x. To get this radical, or this square root by itself, we're going to divide by negative 10. And I'm going to notice here that all three of these numbers are divisible by 2. You could also divide them all by negative 2 if you wanted. So that would give us x minus 9 over negative 5 equals the square root of 3 minus x. In this case, it's one of those situations that leaving the negative in the bottom actually makes this question easier for us. So in order to get rid of the square root, our next step is to square both sides. So on the left-hand side, we're squaring the fraction, which means we would have, I didn't need to write it that far apart, but that's okay. So we would take this fraction and multiply it by itself, okay, with that squared. So remember that means you're going to multiply the numerator together by itself. So that would give us x squared minus 18x plus 81. And in the denominator, negative 5 times itself would give us positive 25. And that's going to equal 3 minus x. Alright, so we have a proportion here. This is technically over 1 there, and so we're going to cross multiply. So 1 times anything is just itself. And 25 times the 3 minus x would give us 75 minus 25x. Alright, we got to move everything over to the left with the x squared, so we're going to add 25x. and we're going to subtract 75. And that's going to give us x squared plus 7x plus 6 equals 0. We're going to factor that into x plus 6, x plus 1, which is going to give us answers of x equals -6 and x equals -1. Again, we would take these answers and plug them back both into the original question, and when you do so, both of them do work. Okay, so you would need to test them, but they do work when you plug them back in. All right, last question here. What happens if we're looking at problems that have parentheses with rational exponents? So we have x minus 9 to the 1/2 plus 1 equals x to the 1/2 power. So one thing with this to keep in mind, the 1/2 power is just the square root. So if it helps you to notice this as the square root of x minus 9 plus 1 equals the square root of x, you can do that. All right, so we have the radicals isolated from each other. So we can go ahead and just work on squaring both sides of this. That means we would get x minus 9 plus 2 square root of x minus 9 plus 1 equals x. Cleaning things up over here, we have x plus 2 square root of x minus 9 minus 8 equals x. So we're going to subtract that x and add the 8. That would give us 2 square root of x minus 9 equals 8. So we're going to divide both sides by 2, which will give us the square root of x minus 9 equals 4. Squaring both sides gives us x minus 9 equals 16. And last step is to add 9, which means we will have x equals 25. Okay, so if you take this, 25 minus 9 is 16. 16 to the 1/2 power is 4. 4 plus 1 is 5. On this side, we have 25 to the 1/2 power, just the square root of 25, which is 5. So both sides equal 5. And so that is it. So keep in mind, still work on separating your radicals, and then you are going to have to multiply a binomial here involving a radical when you square both sides, and then just take the steps from there almost exactly like we've done the past few days. That's it.